So here's a question for you. Convert 0.0010101 to floating point representation. There's 16 bits for the mantissa and 8 bits for the exponent. The solution steps that you want to follow to make sure that you do this correctly are, first of all, identify the sign. Secondly, find the exponent. Thirdly, find the mantissa. And then express your answer to the correct number of bits. So, first step, find the sign. Let's write the number out again. So it's 0.0010101. This is a binary number and we want to represent it in floating point. Basically, we want to get rid of this. So what do we need to do? Well, we need to move this from here to here. Right, but the first thing we're doing is working out the sign. Now, I can't see any negative symbol here. So what we can say is, number one, the sign is positive because there is no negative symbol. So 0 is placed in the signed bit. Okay, so let's go down here and put that in. So I've got an answer grid here, and the signed bit is always the first bit, and it's just used to identify the sign of the floating point number. If you put 0 in, it means it's a positive number. If you put a 1 in, it means it's a negative number. So we've identified that this is a positive number. Okay, so that's that done. Now, part 2, step 2 is find the exponent. Now, I've already started to do that. I couldn't help myself. So here's your decimal point, and you can see here that there's 2 zeros. We don't need these. So we've got 2, and because we're going in this direction, that equals a negative exponent. Okay, so we know the exponent is negative, and we've moved 2 steps, so it's -2. This means it must be expressed in 2's complement. Now, the question tells you that there's 8 bits for the exponent, so it's in 8 bits. So that's worth writing down here in your answer grid, just to remember the exponent is 8 bits. And while we're on the topic, let's go and see what the mantissa is. So there's 16 bits for the mantissa. So let's have a look at this. We've used 1 bit for the sign, and the signed bit is part of the mantissa. So that means there's 15 bits left. Okay, don't forget that. There's 1 bit is allocated for the sign, and it comes from the overall number that's been allocated to the mantissa, if the question doesn't stipulate it. Right, so what is -2 in 2's complement? So let's go through it, and there's no shortcut here, so let's do 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, 5, 6 and 7. That will give us our 8 bits. And let's write down the values at those places. So we've got 1, 2, 4, 8, 16, 32, 64 and 128. Now in 2's complement, the most significant bit, don't forget that, the most significant bit is always negative. Okay, so we need to work out how to do this. So what we could do is find out the positive. Remember, there's a few steps to this. So the first step is, so step 1 is find the positive of 2. So we know that that's a 2, which means the rest of these will be zeros. Step 2 is to flip them. So that becomes 1, 1, 1, 1, 1, 1, 0, 1. And then step 3 is add 1. So let's put in 1. So we've got 1 and 1 is 2. A 2 in binary is 1, 0. The 0 goes in here, carry the 1. 0 plus 0 plus 1 is 1. 1, 1, 1, 1, 1, 1. There is our answer. So this is 2's complement representation of negative 2. And it's in 8 bits because we used 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Let's put it in as our answer. 1, 1, 1, 1, 1, 1. How many is that? 1, 2, 3, 4, 5, 6, 7. There we go. Now, what's left of this mantissa once we remove the exponent? So we're taking away these 2 zeros. So this is what's left of the mantissa. So let's put that in. So it's 1, 0, 1, 0, 1. So 1, 0, 1, 0, 1. Is that correct one? So 1, 0, 1, 0, 1. But it's to be expressed in 15 bits. So that's 1, 2, 3, 4, 5. We've got 10 more to put in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the actual answer is 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0.